Today we're going to be talking about the scientific method and how to solve things through scientific means and the style that we go about doing that. So first up is we're asking you, what are the key components of a scientific experiment? And I'm seeing some things that I like. So some of you guys are pulling in what we did earlier this week with the lab safety stuff. That's great. Good job. So some of you guys are saying masks, gloves, face coverings. Good. I like that. All right. And let's see. I'm also seeing some things. All right. So this is something I need to address right off the bat because I covered this happens every year. When I ask you for your thoughts and ideas, don't Google it. It's painfully obvious when the answer is Googled. All right. Because there are ways that I talk during the day, like the words that I use, and I've been teaching long enough to know the kind of words that you guys use too. So, for example, words like components, constants, validity. I've never ever heard a student use the word validity before in a sentence. So when I see that you guys are using those kinds of words, it makes me think twice. It's not that you're incapable of using the words. You guys are definitely smart enough to know what that means and use it in a sentence, but you'd have to establish the profile of that's how you talk for me to believe it. All right, so right now, please make sure that you are writing down your thoughts. There's no right or wrong answer. You're not going to be penalized if you don't know. Don't write I don't know, but just try. Give me, you know something in your head somewhere about science and how we do scientific experiments. Just put it out there, okay? Don't be afraid to try. All right, so let's see. Let me find one that's not Googled. All right, where'd it go? I just saw it. I don't know where it went. I just saw one I liked, and then I think one of you guys changed it. All right, that's okay. So, in short, here's a good one. Observations, questions, hypothesis, method, results. All right, so you find observations, you make observations, those observations lead to questions. Those questions lead to hypothesis. The hypothesis then leads to you testing what you hypothesized and then looking at those results. That's what I'm interested in. Okay, so I'm going to now I'm going to move on to the next slide, and this one's important because I'm going to go over the ground rules for how we do Nearpods. So, Nearpod grades. There are two ways that we can take grades with Nearpod. First is the way we're going to do today. We can do it where you participate and pay attention as we go through. These ones where we're not taking notes will have a lot of questions, all right? A lot of participation from you. Participation is vital because it's how the district has told me that you are supposed to interact with class. So for example, if I ask you a question and you participate, that's like raising your hand in class and being proactive in the class setting. That also is your trail for attendance. So if someone asks, where you were or in class, this is saying, look, I've been attending Mr. P's class. Here is me participating in that class. And it's how I can double check my attendance too to make sure that I'm doing it right. And that if you have any questions about attendance or get marked absent on accident, you can show me this as well. The second way we take Nearpod grades is guided notes. That's not what we're doing today. So normally I do use guided notes, but I thought this one would be more interactive. We could use this today. But guided notes are just, you follow along, fill in the answers. When you're done, you submit it on Schoology. That's going to be the second type of Nearpod grade. So participate in everything. If you look at that picture, when I pull up these results, it'll show me a class list, first, last names, and then it'll say how you did on each thing. So I can look at, all right, on the first quiz, you scored 100%. On the open-ended one, you also got 100. On the second quiz, you maybe got like an 80. But the last column is the participation. That's what I'm looking for. It's what I highlighted in green. Those numbers, that's what you're going to end up getting on your grade. So say we do 30-point Nearpod assignment. If you only participated in 80% of it, meaning you maybe just didn't feel like answering one or didn't get it in time, then you're going to get 80% of 30 points. So the easiest way to get a grade on this is just participate in everything, give it a try, and it might be awkward at first, but you'll get used to it and things will work out and it won't be so bad, because this is how we're going to have to do it through virtual learning. So please make sure you're participating in everything. I want you to get all the points for this, but you have to participate. So again, what we're covering today is the scientific method for problem solving. All right, so what we're gonna do is we're gonna review the scientific method, and I'm gonna teach you how to explore a problem. When we're done, you guys are gonna make a hypothesis that I will test, and then we'll talk about it on Tuesday. So the scientific process is organized and it's logical, all right? You observe something happen. You take that observation and then you make a hypothesis. Why did that happen, all right? Or what could I change about it? You do an experiment, all right? You test it out. Does this work? Then you come to a conclusion about those results. So what you saw, you come to a conclusion. How did that work? How does that happen? Okay, so you can make an observation. For example, the Wi-Fi in your house is slow, all right? That's, you observe, all right? Your pages aren't loading fast, your game's playing slow on your PlayStation or Xbox, all right? So then you make a hypothesis about what you could do in order to make it better. So, for example, in your observation, you notice that you have you're on a video call, all right? Your brother or sister is playing video games. Your parents are FaceTiming. You are also trying to update your computer in your house, or someone upstairs, another family member is watching Netflix, all right? So you could see that, oh, I have a lot of people that are using the internet right now, all right? So then you can say to yourself, make a hypothesis. If I remove devices online that are online, then I would expect the internet to move faster. Or maybe if I move closer to the Wi-Fi router, then I would expect my internet to move faster. Then you experiment. You try those things. Maybe you shut off the Xbox and you turn your phone off, or you move to sit right next to the Wi-Fi router. That's your experiment. You're testing that out. Then you look at results. Did your internet go faster? Yes or no? All right. Then you come to a conclusion. There were too many people on the Wi-Fi. Or the closer I sit to the Wi-Fi, then the faster it goes. So those are some things that you can think about. That was one I just came up with off the top of my head that you can relate to, but that's how we conduct a scientific process. And you probably do this day in and day out. You don't even realize it, that you do these steps quickly without thinking about them. But in science, we break them down and we go step by step, and we make sure that we're talking about each point, and we make it available for others to test as well. So the first step in anything is to observe. So you observe what's happening in an experiment, you observe what's happening in life around you or in a certain situation, and then you use your senses to collect those. Now, don't use taste. That's the only sense you're not allowed to use. You're not allowed to taste anything in this lab. Maybe in some other labs down the road, but a general rule of science is don't put it in your mouth. Even if when we get back to school and we're working with stuff, even if you were working with sugar and salt in a lab, don't taste it. You don't know if the dishes are clean. You don't know what your partner did with the sample on the way over. It's just bad practice. Don't use taste. So all your observations need to be with everything else besides taste. So your observations can be broken down into two different sections. One is a qualitative observation, and the other is a quantitative. So a qualitative describes qualities. All right, so qualities are things you observe with your senses. That's what we just talked about. So those are like, all right, it is blue, it is tall, this thing is wide, it's far away, it's heavy. So those are the things that we're looking for in a qualitative one. So those are qualitative observations. A quantitative observation is one that describes a quantity, how much of something. So that could be 5 pounds. The can has 12 ounces in it. We are using 100 milliliters of water. It's 30% of the total, something like that. Those are quantitative because they talk about a quantity. Quantities are how much of something you're using. So think about that. Really think about the word. They sound similar, but they're not. So let's test that out. All right, we're going to look at 4 observations. Which one is a quantitative observation? So quantitative. Look at the base word in it. Quantity. Which one of these is a quantitative one? Remember, you get points just for answering, not if you get it right or wrong. All right, so in the Nearpod is what you click. All right, so Carmina, choose that in on the Nearpod screen. Good. All right, so let's talk about it. Quantitative means a quantity. It's how much of something. So which one of these has to do with an amount of something? We do experiments in chemistry class. That is just a regular, average, everyday observation. All right, that's not quantity. It's not how much. All right, we use blue sulfur. We use a blue copper sulfate solution. Right, blue, that is an observation. That's good, but that's qualitative because they're talking about a quality of the solution. The solution is blue. All right, the solution is 10% copper sulfate and 90% water. That's it. All right, you're talking about the 10%. That's a number. All right, we have 2 numbers in here, so C is the correct answer. All right, and this is pretty average. About 2/3 of the class is getting it right. All right, 60% of you guys got it right. If you got it wrong, again, that's fine. It does not affect your grade. It's just that you tried. All right, so now speaking of observations, we're gonna watch a short video of a mini lab. All right, so when you watch this video, I want you guys to think about many observations as you can. What do you observe? What are you seeing in this experiment from the beginning to the end? And then you're gonna write those, you're gonna type those out. So when I change slides, a video is gonna pop up and you're gonna have to hit play on it yourself. So you should see an aluminum pan with a beaker of 250 milliliters of a solution, and it's gonna get dumped into the pan. That's a cork with a candle on it. Lighting the candle. And now put a bottle over top of it. All right. So on the next slide, we're going to talk about what you just observed. What did you just see? List your observations. And I always tell students, the more observations, the better. Explain it to me like I'm blind or I'm an alien from another planet and I have no idea what you're talking about. Explain it with that much detail. The more detail, the better. All right. And I know you guys can see, and you guys can see that video. So use a lot of explanation and observations. All right, Joshua, good job. Terrence, good observations. Todd, good job. All right, nice. That's the kind of detail I want so far, guys, so keep it up. All right, so most of you guys have answered. All right, here's a good one. See the liquid, she put a bowl.
Can you go back real quick?
All right, let me read this real quick. She put a bowl on a tiny candle inside. She grabbed the bottle, put it over the candle, and the liquid started to rise up. Okay, that's good. Okay, let's see. All right, I seen him pour liquid, and he put a candle on top of a cork in the liquid. After that, he put a bottle over it, and the liquid began rising. All right, those are all very good observations. All right, so your observations should definitely be more than one sentence. Okay, so some of you guys put in like fragments of a sentence. All right, so make sure you're getting full sentences in. All right, so yeah, if you use one sentence or less, I need more. All right, I'm getting ready to move on, so make sure you get it submitted. All right. All right, so now we're going to move on to our hypothesis. The hypothesis is based in an if-then statement. So it's an if, comment, then what will happen. So if this thing, then that thing. So the observations will predict the outcome of the experiment. Now, the biggest problem I have with this is that students will often think that they need to get the hypothesis right. Being right has nothing to do with the hypothesis or your grade. So if you are doing a lab in school and I ask you to make a hypothesis, you don't have to be right. All right? As long as the hypothesis you make is relevant to the experiment and makes sense, that's what I'm grading on. I'm not grading on whether you were right or wrong. I've seen many students go back and fix their hypothesis so they were right. Being right has nothing to do with it. The vast majority of science, all the way up to the highest levels in college and beyond, hypotheses are wrong all the time. All the time. It is very, very rare that a hypothesis is correct. So don't be worried if your hypothesis is wrong. Also, students sometimes will wait till the end of an experiment to then go back and make a hypothesis. It's like knowing the end of the movie before you see it. You have to do the hypothesis first before you do the experiment. So it's going to be an if-then statement. So that's what we're going to do. In the next two questions I'm going to ask you, they're going to be two sections. Question one, it's going to be list things you can change, because like I says here, change is the first part of the hypothesis. Then what will that change be like? What will happen if you change it like that? So I need you guys to kind of piece these two questions together. What change can I make? And then the following question is going to be, what will happen if I make that change? Include lots of details. So I'm gonna give you guys like 2 to 3 minutes on this one because it requires some thinking. Don't skimp out on this. Give this some effort. So in the video, list 4 things that you could change about the demonstration you saw. So look at the demonstration. You saw a pan of liquid, you saw a bottle, you saw a candle, you saw a cork. All right, what could you change in that experiment that would affect the outcome of it? So changing something like say using your left hand instead of your right hand, that's not going to do anything. All right, so don't say something like that. Say something like the color, the size of the bottle, things like that. What could you change in that experiment? All right. Remember, I need 4 things. Sincere, you only gave me 1. I need 4.
It's R.
Say that again?
It's R, like it's what we would do.
Yes, exactly.
Okay.
All right. 1 more minute. Then we got to move on. Okay. So here's what I'm looking for. All right. This is pretty good. So this is Marquez. All right, I like this one a lot. You kind of went on and did the next part without it, before I could even say it. So you can copy paste this one real quick into the next part. But you could change the candle size, you could change the bottle size, you could change the color of liquid, you could change the pan. All right, that's good. That's what I'm looking for. Is that those kinds of changes is what I'm looking for you to see. So now I want you to really kind of think about this. Think about what you would do. All right. Then what I want you to do is now how would that change the results? Okay. So some of you guys did that already. All right. So just copy or retype that last part in about how it would make the change. So what would those changes do? How would they affect the experiment? And that's what you list here. All right, guys, come on. All right, Todd, I like your answer. All right, 1 minute. Then I got to move on because we only got about 8 minutes left in class. Remember, this is part of your grade, so I see a lot of people at the top aren't typing anything in. All right? Your participation in this is tied to your grade for today. All right. So here's a good answer. All right, I think if I change the size of the cup, it will make almost all the liquid go in there, and the candles bigger would do the same thing too. If I change the color, I think nothing would really change. It would stay the same unless I got good. You change the type of water to like juice or something. Excellent. This is perfect. This is Todd's answer. Great job. All right, so now what we're going to do is we're going to turn this into an hypothesis. Okay, so here's how this is going to work. You're going to put this in one sentence. So this is a one sentence answer. If you do the change that you said, then what will happen? So, for example, if I use juice instead of water, then what do you think would happen? This is an example. All right, I'm going to use Todd's example. He said if I use juice instead of water, then not as much water gets sucked into a jar. It's this if-then statement. So if question one, the answer you said to question one with the what you would change, that goes in the if. Then that's like a space, what would happen, which is in question two that you just answered. So you're kind of plugging those things into this one sentence. If you change something, then you would expect this thing to happen. So what I'm going to do is I'm going to take the most requested hypothesis that's done correctly, and I'm going to do that as an experiment, and we're going to talk about it on Tuesday. So I have some of it set up already. I'm ready to go. I'm going to record it, and we'll go from there. So make sure this looks good and is in a nice if-then statement. If what changed, then what would happen. So you're predicting what happens in the second part if you changed this part of the experiment. Okay, 1 minute. Edwin, I like yours. 30 seconds. All right. I like this one. All right. If I were to use a smaller jar on top of the cork of the candle, then the liquid would fill up the whole jar. All right. Good. I like that. So the last thing we're going to talk about today is designing the experiment. When you design the experiment, you need a control, independent variable, and dependent variable. The control is the comparison. So it's going to be the regular experiment you're comparing your results to. which was going to be the video that we already saw today. The independent variable is the cause. So if something's independent, it doesn't need help. If you're independent, you don't need help buying groceries, you don't need help paying bills, you don't need help getting anywhere, you can do all that yourself. A dependent variable is something that depends on the independent variable to change. It won't change unless the independent variable changes first. So the independent variable for the Wi-Fi situation could be the one that I talked about earlier, the strength of the signal, could be how far you are away from your router. The dependent variable will be the speed of your Wi-Fi. So when you change the distance from the Wi-Fi, the strength of the Wi-Fi would change. So which one's dependent and which one's independent? All right, that's kind of what we're looking for. Which one depends on the other? So going into our exit ticket, our last question, I want you to look at these examples. Which one of the examples in A, B, C, and D will depend on something else to change? So which one, if you changed part of your experiment, which one of these other things would change because of it? So really think about what causes the change and then what would be the effect. So in this video demonstration, what is the dependent variable? Which one, A, B, C, or D, depends on something else in order to change? All right, this should take you 30 seconds max. Again, it's not about right or wrong. It's about just doing it. So make sure that you guys are just selecting what you think is correct and going from there. All right, so we have more than half, so I'm going to go ahead and explain this, and then we'll be on our way. So the dependent variable in this demonstration is going to be the height of the water in the jar. And it's going to be that because the height of the water in the jar will change based on these other parts. If you have a different amount of water in the pan, if you have more water, it could be higher, or if you have less water, it could be lower. If you use a different size of the bottle, that could also change the height of the jar. Or the number of candles in the jar could also change the water. So this one is the only one that depends on other things in order for it to change. Okay, so that's all I got for you today. Make sure that you answer this question before you go. Over the weekend, make sure you are looking to make sure you have all your assignments up to date. Check Schoology, send me a message if you have questions, or show up to my office hours. My office hours today are from 11 to 11:50 with the password Withrow Pescatress OH.